Hello students, welcome back. I am Alejandro from Victory IB and CAIE Online Academy. During this video we will be discussing parts B and C of the second problem of the 2019 AP Physics 1 exam. Now this problem, as well as the entire exam, is divided in subparts, so make sure you watch all the previous videos and the following to have a complete understanding of all the concepts that are discussed and involved during the exam. Let's get started.
Okay, now part B. Now suppose neither block's mass is much greater than the other, but they are not necessarily equal. The dots below represent block A and block B, as indicated by the labels. On each dot, draw and label the forces, not the components exerted on that block after release. Represent each force by a distinct arrow starting on and pointing away from the dot. Okay, which are the forces acting on each of the blocks. First of all, each block is affected by its own weight, so pointing downwards, we'll label it as mass of A times gravity, or just weight of A. Same goes for block B. Mass of B times gravity. They are on Earth, they are affected by its own weight. Now, block A is laying on a tabletop, so a normal force will be acting upwards. We'll label this one as normal force, or normal reaction force, or whatever you're used to. Normal of A. B is not affected by a normal force, it is not in contact with any surface, it's just hanging from a string. That string will produce a tension acting upwards on B. I'll just label it with a T, or you can just write the entire word tension. Sorry, tension. That tension is acting rightwards on A. And that's it. Those are the 5 forces, 3 of them which are acting on A, 2 of them are acting on B. There is no force acting leftwards on A since there is no friction. In part C, we are asked to derive an equation for the acceleration of the blocks after release in terms of ma, mb, and physical constants as appropriate. If you need to draw anything other than that you have shown in part B to assist in your solution, use the space below. Do not add anything to the figure in part B. You're expected to leave this as it is. So, okay, I'll just write it down here. So, all we must do is to write Newton's second law, force equals mass times acceleration, and we'll do it 2 times, once for object A and once for object B. Now, since we are going to be writing this equation twice, it's important to understand that object A is going to be pushed rightwards, so we will be considering this tension force as acting in the positive direction for A. But object B will be moving downwards. So we'll consider the downwards direction as a positive direction when writing our equations for block B. So there is only one force acting in the direction in which object A is moving, which is the tension. I will be representing that force with a capital T. So for object A, we'll have this equation. T, the only force, equals mass of A times the acceleration. Now, I'm not going to write the acceleration of object A because the acceleration of object A, and the acceleration of object B, they're both identical. We know that because they are both attached to the same string, and the string is now, it's inextensible. That means that whatever is happening with object A from left to right, it's the same thing is happening with object B up and down. If the string were an extensible string, if there were no string at all, object A might be able to move with a different acceleration than the one of object B, which is not the case in here, so we don't need to write acceleration of object A, acceleration of object B. And a similar but not identical argument can be used for the tension. We were told during this problem that the pulley was frictionless and without mass type of pulley, which they do not exist in the real world, but they only live within the physics problem universe. That type of pulley, since it has no mass and has no friction, does not need a net torque to start moving. That's why the tensions on both sides of the pulley are the same. The tension that it's pulling upwards from B is the same tension as the one acting rightwards for A. So that's why we haven't identified tensions as tension on A and tension of B. It's the same tension because it's the same string, and there is no need for a net torque to start rotating the pulley. We'll go deeper into that argument later on the problem. So for object B, downwards as positive, we'll say something like mass of B times gravity, that's its own weight, minus the tension, the same tension, equals mass of B times the acceleration, same acceleration for both. So all we must do is to solve the set of two simultaneous equations. T is unknown to us at this point. T is unknown to us at this point. Same goes for A. Those are two unknowns. T is unknown, A is unknown. So of course we have a set of two simultaneous equations, which we are going to solve but by adding both equations. If we just add them, adding all the terms on the left side and adding all the terms on the right side, we can mathematically cancel the tension out because it's having a positive sign on one of the equations, a negative sign on the other equation, so it's cancelled out. The only net force that is acting on the system is, of course, the weight of B, which is the only force responsible of moving and accelerating the system. And on the right side of the equation, we have a common factor, which is A. We'll just write mass of A plus mass of B multiplied by the acceleration. As a final step, we'll take this brackets, the total mass of the system, dividing to the other side. So we will be able to say something like acceleration equals mass of B times gravity divided the total mass of the system, or mass of A plus mass of B. That's it. Let's read it once more. What are we asked to find? Derive an equation for the acceleration of the blocks after release in terms of mass of A, mass of B, and physical constants as appropriate. This is what we did in here. So this is our final answer. This is an equation for the acceleration.
Okay, thanks for watching. Please watch our next video for the remaining part of the problem as well as the remaining part of the exam. Also, don't forget to register on our website www.victoryonlineacademy.com for a free demo registration. I'll see you on the next video.